Good evening, all of you. So yesterday, I think we completed solutions, right? Now to do next chapter, solid state. So today, let us see solid state. So let us see. Yeah, solid state. So this is also from physical chemistry. So in this chapter, so you may get one or two questions. Sometimes they are giving one question and sometimes they are asking two questions, right? So let us see. So solid state is all about crystalline solids. Crystalline solids. So these crystalline solids, they are divided into first one, molecular solids. What are they? Molecular solids. In that first one, polar molecular solids. Polar molecular solids. In this, dipole-dipole interactions are present. Dipole-dipole interactions will be present. And examples for this is Cl, SO2. Next one, non-polar solids, non-polar molecular solids. So in between them, van der Waals forces or dispersion forces. Examples, I2, P4, S8. Third one, hydrogen bonding molecular solids. So what are bonds? Which bonds are present? Hydrogen bonds. Example, ice, ammonia. In ammonia also hydrogen bonds are present. This first one. Second one, ionic solids. In ionic solids, electrostatic forces. Electrostatic forces are present. Examples, NaCl, copper sulfate. These are all ionic solids. Next, third type, covalent or metallic solids. Sorry, not metallic, network solids. Covalent or network solids. What are they? Since this covalent bonds are present. Example, diamond, graphite. So all these are covalent or network solids. Last one, metallic solids. So metallic bonds are present. Between the constant particles, metallic bonds are present. Examples, copper, iron, nickel, all metals. Okay. Next, unit cell. What is unit cell? The smallest repetitive portion. The smallest repetitive portion. In the crystal lattice. It's called unit cell. Then types of unit cells. How many types of unit cells are there? First one, primitive unit cell. What is primitive unit cell? So constituent particles are present at corners only. Second one, centered unit cells. Centered unit cells are again face centered, body centered, or end face centered. Face centered, body centered, and end face centered. So this is about centered unit cells. Done. The next packing efficiency. So the first one, simple cubic unit cell. Packing efficiency in simple cubic unit cell. Formula. What is formula for packing efficiency? Volume occupied by spheres by volume occupied by unit cell into 100. So for simple cubic unit cell, there is only one atom, that means only one sphere, that is 4 by 3 pi r cube, by volume occupied by unit cell, that is a cube. So that is 4 by 3 pi r cube by 2r whole cube. into 100. So finally what you will get, 52%. Next, face-centered unit cell. Same cell, then you will get for face-centered 74%. Body-centered unit cell, you will get 68%. Next, radius ratio. Radius of smaller ion, that is cation, by radius of larger ion, that is anion. So simply write R plus by R minus. Radius of cation by radius of anion, that is what we call radius ratio, right? If radius ratio, this is radius ratio, then coordination number. Based on that, we'll determine its shape. What is it? Less than 0.155. Coordination number is 2. Shape is linear. 0.1552 to 0.225. Coordination number is 3. So its shape will be planar, triangular. Next, 0.225 to 0.414. Coordination number is 4. It will be tetrahedral. Next, 0.414 to 0.732. 6. Coordination number. Shape will become tetrahedral. Next, greater than 0.732. Coordination number will be 8. And this is body-centered cubic unit cell. Okay. Next, if the arrangement is body-centered cubic unit cell, let us consider hexagonal close packing. Then the arrangement will be AB, AB, AB type. For CCP, cubic close packing, or face-centered cubic unit cell, then it will be ABC, ABC, ABC. Next, tetrahedral voids and octahedral voids. Let total number of atoms be n. Then number of tetrahedral voids is equal to 2n. The number of octahedral voids is equal to n. Done. Next, for FCC like structure, like an NaCl, sodium chloride, edge length A is equal to 2 into radius of cation plus radius of anion. For BCC, edge length root 3a is equal to 2 into radius of cation plus radius of anion. Then density, it is given by Zm by Na cube. So Z is total number of atoms in unit cell. M is molar mass. N is 6 Avogadro's number, 6.023 into 10 power 23. And A is edge length. A is edge length. That is volume. A cube means volume. No, this is not. A cube means volume, right? So then we have some theory part, crystal defects. Okay, but we don't have time to discuss all those things. Let us move to directly problems. So let us see problems. Moving to numerical part. So let us start with some simple questions. Then we'll move to some tough questions also. Let us start with some simple questions. First question. The number of carbon atoms. The number of carbon atoms per unit cell of diamond is, options are 6, 1, 4, 8. So we need to find out the number of carbon atoms. Number of carbon atoms. So this interesting question. If you consider diamond, so carbon forms cubic close packing and also occupying half of tetrahedral voids. Half of tetrahedral voids. So CCP. So CCP is almost similar to FCC cell. So if you are having any confusion, then just always replace CCP with FCC. Now let us consider in FCC, total number of atoms, 8 corners. Each corner contributes 8 into 1 by 8, 6 faces. Each face contributes half. And here half of tetrahedraloids. Half of tetrahedral. First you can find out this. 1, here 3, total 4. So in FCC, now total number of atoms, how many? 4. Therefore, tetrahedraloids will be 2 into n, that is 2 into 4, that is 8. But according to the question here, half of tetrahedraloids. So that is, but carbon occupies half of tetrahedraloids, that is equal to tetrahedraloids 8. Half means 8 into 1 by 8, that is 4. Okay. So what you're getting here, total from FCC it is 4 and tetrahedral also 4. So therefore, total number of atoms in the unit cell equal to 4 plus 4, that is 8. So 8 will be your answer. Yes. Right? So we'll move to the next question. Question number 2. In a face-centered cubic lattice, a face-centered cubic lattice, a unit cell is shared. A unit cell is shared equally by how many unit cells? By how many unit cells? So let us see. So we know that, let us see answer for this question. So options A 2, B 4, C 6, D 8. Okay, now we know that if you consider face-centered cubic unit cell, each face is shared by 2 unit cells. Like that, how many faces are there? 6 faces are there. So 6 faces will be shared by other 6 unit cells. By how many unit cells? A unit cell is shared equally by how many unit cells? Now let us suppose so let us consider face-centered unit cell. This is one cubic unit cell. Now here, each face is equally shared by this. Let us suppose if you consider this, you consider this face. Okay. So this face is shared by another unit cell, right? Like that, each face is shared by some other unit cell. Like the total, how many units, how many faces are there? 6, isn't it? So what we can conclude here, each face is shared by another unit cell. So like that, how many faces are there? So therefore, total 6 faces are shared by another 6 unit cells. So answer will be C. Okay. Next question. Third question. Right option for the number of tetrahedral and octahedral voids. The number of tetrahedral voids and octahedral voids in hexagonal primitive unit cell. Hexagonal primitive unit cell are options 12 and 6. That means 12 tetrahedral voids and 6 octahedral voids. Second option 8, 4, 6, 12, 2, 1. Then how to determine? First, you need to find out how many total number of atoms are there in hexagonal unit cell. In hexagonal unit cell, total number of atoms, it is equal to n, that is 6. If n is equal to 6 means number of tetrahedral voids, that is 2 into n. So 2 into 6, 12. The number of octahedral voids is equal to n, that is 6. So total number of, the question is about tetrahedral voids and octahedral voids. How many tetrahedral voids are there? 12. How many octahedral voids are there? 6. 12, 6. So this will be your answer. So next question. Next. A compound is formed by cation C and anion A. The anions form hexagonal close packing lattice, and the cations occupy 75% of octahedral voids. The formula of the compound is option C4A3, C2A3, C3A2, C3A4. Done, sir. Now a compound is formed by cation C and anion A. The anions form his CP lattice and cations occupy 75% of the octahedral voids. Then the formula of the compound is that we need to find out here. So let us proceed. So this is also hexagonal, isn't it? Where is it? Yeah, here. Is also hexagonal close packing. Just now we completed this hexagonal unit cell. It's in the total number of atoms in hexagonal unit cell. How many, sir? 6 here. So let us start from that point. Total number of atoms in hexagonal close packing. That is 6. That is equal to n. Okay. Then number of, so anions form his CP. That means that 6 is equal to number of anions. It's equal to number of anions. But number of cations, what is given? 75% of which octahedral, I think, right? 75 octahedral voids, yes. Octahedral voids. So if n is equal to 6, number of octahedral voids is equal to n, that is equal to 6 again. Okay, so now cations. Let us proceed. Now, number of octahedral voids, got it, is 6. Therefore, number of cations is equal to 75%. That means 75 divided by 100 into octahedral voids. That is 6. 6 into 75 by 100. This is 3. This is 4. Right. So 18 by 4 or 9 by 2. This is about cations. What you will get? Cations 9 by 2, anions 6. Okay, then what you will get? C9, 8, 12. That means C3, A4. What you're getting? So multiply this. 2 into 6, 12. So C9, 2 into 6, 8, 12. That means 8, 12. So which is common? 3. 3 3s are 9, 3 4s are 12. So C3, A4 is your answer. Where is it? C3, A4. Done. So this is one more model. Next, similar model, because this model they're asking frequently. This and density calculation. These two are frequently they're asking. So next model. Question number 5. So let us see. The compound formed by elements. Compounds. Sorry. compound formed by elements X and Y crystallizes in a cubic structure in which the X atoms are at the corners of a cube. At the corners of a cube. And the Y atoms are at the face centers. At the face centers. The formula of the compound is options XY3, X3Y, XY, XY2. Yeah, let us check it. So now a compound formed by elements X and Y. So two elements are there, X and Y crystallized in cubic structure in which X atoms are. First, let us find out number of X atoms. So they are present at corners of a cube. So number of atoms at corners, 8. Each corner contribution 1 by 8. So total 1 atom. Then Y atoms. Y atoms are at the face centers. Number of atoms at face centers, that is equal to 6 into each face center contributes half of the atom. That means 3 atoms. So now what is formula? X1, Y3 implies XY3. So first option, XY3. Done. Next, one more question we'll see. Same model, sir. And after that, we'll change the model. 6th question. Structure of a mixed oxide is cubic close packing, CCP. It is composed of oxide ions, O-2. Then 1/4 of tetrahedral voids are occupied by divalent metal A, and octahedral voids are occupied by a monovalent metal B. Then the formula of the oxide is, options AbO2, A2BO2, A2B3O4, then D, AB2O2. So let us see. So what is structure given here? CCP. So who is present in CCP? It is composed of oxide ions. So first let us start with total number of atoms in CCP. It resembles FCC. In FCC, total number of atoms, 4. So 4, which ions are present? Oxide ions are present. 4 oxide ions. So this is equal to N. Total number of atoms in CP, N. So tetrahedral voids, 2 into N. That is 2 into 4, 8. Octahedral voids equal to N. That is 4. Okay. Now let's proceed. By using this data. Let us proceed with the data we obtained here. Now in that 1/4 of tetrahedral voids, 1/4 of tetrahedral voids are occupied by divalent metal. So number of metal atoms A, 1/4 of tetrahedral voids. Tetrahedral voids, how many we got? 8. That means total metal atoms of A, 2. Then octahedral voids are occupied by monovalent metal B. Number of metal atoms B is equal to octahedral voids. That is, how many octahedral voids? 4. Therefore, what will be the formula of the metal oxide? What it will be, sir? A, how many A? 2. B, 4. Oxide ions. How many oxide ions are there? 4. So what you are getting? AB2, O2. AB2, O2. So this is formula of the compound. Where is it? Last option, AB2O2. Done, sir. Next, we'll move to next model then. 7th question. A solid compound XY has NaCl structure. If the radius of the cation is 100 picometers, Okay. The radius of the anion will be the radius of anion y minus will be A 275.1 picometers, 322.5 picometers, 241.5 picometers, 165.7 picometers. So let us solve this. We know that for NaCl, radius of cation by radius of anion will be 0.414. Then what is given there? Radius of cation is given. This is given 100. So 100 by, we have to find out radius of anion, that is 0.414. So therefore, radius of anion is equal to 100 by 0.414. So 100 by 0.414 will be 241.5 picometers. This is your answer. Right? So in the beginning, we have seen, right, radius ratio. I gave you the table. Yeah. So radius ratio of NaCl 0.414 to 0.732. So it is coordination number in NaCl 6. So generally consider the first value, that is 0.414. Okay. That is, we have taken 0.414 there. Done. We'll move to next question then. Question number 8. The edge length of FCC unit cell is 508 picometers. 508 picometers. If the radius of the cation is, 110 picometers, then the radius of the anion is options 144 picometers, 398, 'So let us solve this question. So in face-centered cubic lattice, the edge length of the unit cell I think I gave you formula, right? Edge length formula in FCC unit cell, right? What is that formula? Did I give you? Yeah, here. In FCC like structure, so this is the formula. A is equal to 2 into radius of cation plus radius of anion. Right. So A is equal to 2 into radius of cation plus radius of anion. What is A? Edge length is 508. So 508 is equal to 2 into radius of cation, it is given 110. Radius of anion we need to find out. So bring 2 here. 2 in 508. How many times, sir? 2. So 100 plus 110, sir. 110 plus radius of anion is equal to 508 by 2. So how many times it will go? 2 2s 4, 2 5s, 2 4s, 254. And radius of anion will be 254 minus 110. 254 minus 110. Not you will get. 254, 154, 154 minus 10, 144 picometer. So option will be A. Done, sir. Next question. Ninth one. The vacant space in BCC unit cell. The vacant space in BCC lattice. BCC lattice unit cell is options 48%, 23%, 42%, 26%. Okay. In BCC, what is packing efficiency, sir? Means that is volume occupied. How much we got? 68%. Then here, volume unoccupied. $100 minus 68. What is that? 32%. So vacant space in BCC lattice is 32%. Next one. 10th question. A metal crystallizes with a face-centered cubic lattice. The edge of unit cell is unit cell is 408 picometers. Now the question is the diameter. The diameter of metal atom is. This is the question. Options are 288 picometers, 408 picometers. C, 144 picometers. D, 204 picometers. This is the question. Now let us see. For FCC, face-centered cubic unit cell set, radius formula R is equal to A by 2 root 2. So here A is given, and we need to find out R, right? So what is A? 408 by 2 root 2. 408 by 2 root 2. So 2 in 408, how many times? 2 2s, 204. So 204 by root 2, 1.414. Now what you will get? Four not 8 by 2 root 2. What you are getting? 204 by 1.414. And what you got answer? It is equal to 144 picometers. But this is not what we need. We need diameter. So diameter is 2R. That is 2 into 144. That is 288 picometers. Answer. So this is one more problem. Let us see one more question. Different model you'll see now. So write down the question. A metal has, so question number 10 is over, question number 11. A metal has a FCC lattice. The edge length of the unit cell is, the edge length of unit cell is 404 picometers. 404 picometers. The density of the metal is, density is given. The density of the metal is 2.72 grams per centimeter cube. The molar mass of the metal is, the molar mass of metal is, options 27 grams per mole, 20 grams per mole, 40, 30. Done, sir. Then we have to find out molar mass of the metal. So it is given FCC. What is formula? Density is equal to Zm by NAQ. Edge length is given Z. Z is total number, right? Z for FCC, that is 4. Molar mass we need to find out. Remaining all are we are having. So here 1 picometer is equal to 10 power minus 10 centimeters, because it is given in centimeter cube. Then you convert what we need, molar mass, make M as subject here. So M is equal to rho into N into AQ by Z. Now substitute all those values. Therefore, M is equal to what is given, sir? M is equal to rho density 2.72, Avogadro's number 6.023 into 10 power 23 multiplied by edge length AQ. A is 404. 1 picometer is equal to 10 power minus 10 whole cube divided by Z. Z is total number of atoms. That is 4. So multiply all those values and find out. What is that value? Done? Anybody got answer? So actually you should get 27, sir. Answer should be 27 grams per mole. This should be your answer. And one more question we'll see. 12th question. Lithium metal crystallizes. Lithium metal crystallizes in a body-centered cubic unit cell in BCC. If the length of the side of the unit cell of lithium is, if length of side of the unit cell, unit cell of lithium is 351 picometers. The atomic radius of lithium will be A, 151.8 picometers, B, 75.5 picometers, C, 300.5 picometers, D, 240.8 picometers. So here it is given, it is BCC. In BCC, radius formula √3/4 into edge length A. Okay, which is equal to √3/4. What is edge length given? 351, I think, right? Yes. So √3/4 into 351. So find out this value, that will be our answer. Find out later, it will be 151.8 picometers. Direct answer. So directly substitute those values in the formula, then we'll get answer. Next, one more question we'll see, then we'll wind up this session. The fraction of total volume, volume occupied by the atoms present in a simple cube is options pi by 3√2, next pi by 4√2, next pi by 4, pi by 6. Okay, so the fraction of total volume occupied in simple cube. So what is formula? Total number of spheres means volume occupied by total number of spheres by volume of unit cell. So then what is formula, sir? How many spheres in a simple cubic? 1. That means 4/3 pi r cube. By in simple cube, A is equal to 2r. So here A cube means 2r whole cube. What you will get? 4/3 pi r cube by 8r cube. That is 4/3 pi r cube by 8r cube. R cube gets cancelled. Then 4 in 8, 2 times. Then what is remaining? Pi by 3 into 2, 6. So pi by 6 euros answer. Where is it? Fourth option. So pi by 6. So this is our uptime. So this is about total volume occupied by spheres in a simple cubic unit cell, right? So these are some important models in solid state. Remaining models will check in next session, right? So I think tomorrow we have to start solutions over. Say solid state is over in physical chemistry. Then I think electrochemistry. We'll say electrochemistry tomorrow. Okay. So then we'll meet again on tomorrow then with electrochemistry. Okay. Okay then. Meet you tomorrow. Good night, all of you.